Hello, this is Dr. Eddie Morgan over at Clovis East High School, and I'd like to go over the Unit 10 review with you to help you prepare better for the next test. The first question says, for each statement, underline the hypothesis and circle the conclusion. So first we have to decide what is the hypothesis and the conclusion of a conditional statement. Conditional statements have the form of if P then Q. In other words, if it is snowing, then it is cold. And the P is our hypothesis. So the hypothesis, if it is snowing, the conclusion is Q, it is cold. Note, by the way, that for technical reasons, the hypothesis and the conclusion do not include the words if and then, because we may be switching them later on. But in the form if P then Q, if it is snowing is the hypothesis. Then it is cold is conclusion. So the key words you're looking for is if and then. The hypothesis has the if and the conclusion has the then. So we look up here, if I study for the test. So next to the if is I study for the test. That's my hypothesis. Then I will get a higher grade on the test. I will get a higher grade on the test then is my conclusion. So that's what I circle. Likewise in B, if a figure has three sides, so the hypothesis, the if part, is a figure has three sides. Then the figure has a triangle. The figure is a triangle is my conclusion. In problem 2, we're asked to complete a 2-column proof. Now in one sense, all we're doing is solving the problem like we have before, but we have to give our reason for each step. So if I look at this, let's see what we would do if we were solving this. First of all, if I look at this, when we're trying to solve for x, one of the things we typically try to do is to distribute things to get the variables out of parentheses. So the first thing I might do is multiply the 5 times the x and the 5 times the minus 2 and get 5x minus 10 and then plus 8 equals minus 3. What property did I use? What allowed me to do that? That was the distributive property that I used. Next, I might look on the left and the right side and see if there's any terms to combine, and I notice here negative 2 and 8 can be combined. Negative 10 plus 8 is negative 2. So we write down 5x minus 2 equals minus 3. What was the property there? I simply call that combining like terms. Remember, you can only combine on one side or the other side. You don't combine across the equal sign. At this point, we have our typical two-step equation. And the way we typically solve that is, first of all, we undo any numbers that are added or subtracted to the x term. In this case, there's a subtract 2, so the opposite of subtracting 2 is add 2, and I do this to both sides. So if we add 2 to both sides, it eliminates it here on the left side and leaves me with 5x equals negative 1. What property did we use? We used the addition property of equality. That says if you have an expression that's equal and you add the same number to both sides, the expression is still equal. Finally, we have the expression 5x equals negative 1, and we want to get rid of the 5. How do we undo 5 times x? Well, the opposite of multiplying times 5 is dividing by 5. So we divide both sides by 5. That's part of the equality. And 5 divided by 5 is 1, so we're left with x equals negative 1 over 5th. What property did we use? Well, we divided both sides by 5, so that's the division property of equality. In the next problem, we're asked to prove, looking at the figure, we're asked to prove that given that angle 1 equals angle 2, and I'm just going to mark it right here, given that angle 1 is congruent to angle 2, can I prove that angle 3 is congruent to angle 4? Well, first thing, when you're doing a proof, the first thing you almost always write down is the given statement. So I'll put that the measure of angle 1 is congruent to the measure of angle 2. I call that given, although technically we could say that's a function of congruent angles. If two angles are congruent, then their measures are equal. Now the next thing I want to look at is what other things are equal. Well, notice that angle 1 also equals angle 3. How do I know that? Because you see they're across from each other. They are vertical angle theorem. All right? Likewise, I know that angle 2 equals angle 3. Why? Because if I take, here's angle 1 equals 2, here angle 1 equals 3, So if I know this equals here, I'm going to take this and I'm going to substitute it into here. So by the substitution property, or I could say the transitive property. Transitive is just another word for substitution. If 1 equals 2, and if 2 equals 1 and 1 equals 3, then 2 equals 3. All right. So I have proven that 2 and 3 are equal. And notice, by the way, when I marked it here, I should have noticed if these two are equal, then these are equal, then, oh, by the way, these must be equal too. Similarly, my next step, I know that 2 equals 4. Why do I know that 2 equals 4? Because they're vertical angles too. And then by the same process, notice that if 2 equals 3 and 2 equals 4, then by the transitive property, 3 must equal 4. And therefore we've proved it. Again, another way of looking at the transitive property is the substitution property. I could say, well, if the measure of 2 is 3 and the measure of 2 is 4, if I take this and substitute it in here, then I get that 3 equals 4. And so now we've proved that if 1 equals 2, then 3 equals 4. By the way, what's the measure of every angle? If all 4 of these are the same angle and they add up to a circle 360, that means each of these angles is 90 degrees because 360 divided by 4. In problem 4, we're given two angles, angle M and N, and we're told that they are vertical angles. Vertical angles are across from each other and are congruent. And then we're also given two algebraic expressions. The measure of angle M is 2x plus 42, and the measure of angle N is 5x minus 3, and we want to find out what is the measure of angle M. First of all, because vertical angles are congruent, their measures are congruent. So we know that the measure of M equals the measure of N. Now we're going to substitute in the two algebraic expressions that we have for these. So for M we put in 2x plus 42, and for N we put in 5x minus 3. We're now in a position where we can solve for x. Now be careful at this point. We are not being asked what x is. We're being asked what M. But to find M, we have to find x. So now we have a simple equation. Let's get all the numbers on one side and the variables on the other. So my first step is I'm going to subtract 2x from both sides. That's going to get the x's off to the left and the x's on the right. So we have 42 equals 3x minus 3. And now we'll get all the numbers on the left. So I'm going to add 3 to both sides, and that gives me 45 equals 3x. And now how do we undo 3 times x? The opposite of multiplying by 3 is dividing by 3. So we divide both sides by 3. And that leaves us with 15 equals x, or x equals 15. Now we haven't solved the problem yet. We've just found what x is. But now that we know x, we can find the measure of M by plugging into our original expression. The measure of angle M is 2x plus 42, so we just simply put in 15 for x. So 2 times 15 plus 42, or 30 plus 42, and so finally our answer is the measure of M is 72. And by the way, if you wanted to check your answer, all you'd have to do is put that back into the next one. 5 times 15 is 75 minus 3 is also 72, which is what we would expect if we did it right, because M and N are congruent angles. Problem 5 is somewhat like problem 4 in that we're given information about two angles and use that information to find what their measures is. In this case, it says that angle Y and angle Z are supplementary angles. That means these two angles, their measures add up to 180. We're also given information about the algebraic expressions. For example, the measure of angle Y is 3x minus 7, and the measure of angle Z is 2x plus 12. So let's get started. First of all, because they're supplementary angles, these two angles, their measures add up to 180. So measure of angle Y plus measure of angle Z equals 180. So let's substitute in for each of these their algebraic expressions. So for measure of angle Y is 3x minus 7, and the measure of angle Z is 2x plus 12. And now we're going to solve for x. We need to find x in order to find the measures. So first thing I want to do is combine like terms. So 3x plus 2x is 5x, and minus 7 plus 12 is also 5. So we end up with 5x plus 5 is 180. And now we have a simple two-step equation. We're going to undo the plus 5 by subtracting 5 from both sides. And then we're going to undo the 5 times x by dividing by 5, and we end up with x equals 35. Now that we've found x, we can establish what the measure of y and z is. So we're going to plug in, measure of angle y is 3x minus 7, so let's put in 35 for x. 3 times 35 minus 7, or 105 minus 7, 98 degrees for the measure of y. The measure of z is 2x plus 12. So again, put in 35 for x. 2 times 35 is 70, plus 12 is 82. And now we can check to make sure we got our answer right by simply adding these two together, and we see they equal 180, so we know we got the problem right. Problem 6 is just like problem 5, except instead of the angles being supplementary, they are complementary. Supplementary angles add up to 180, complementary angles add up to 90 degrees. So let's get started. First of all, because they add up to 90 degrees, I know that the measure of angle C plus the measure of angle D is 90 degrees. Let's substitute in the algebraic expressions. Measure of angle C is 5x minus 3, and the measure of angle D is 2x plus 30. And just like before, let's combine terms. So 5x plus 2x is 7x, minus 3 plus 30 is 27. So we end up with 7x plus 27 equals 90. Our two-step equation, undo plus 27 by subtracting 27, undo 7 times x by dividing by 7, and we end up with x equals 9. So now we can plug them back into our equation, our expressions, and find out what the measure of these angles is. So measure of angle C is 5x minus 3, so let's put in 9 for x. 5 times 9 is 45 minus 3 is 42 degrees. That's the measure of angle C. Likewise for D, the expression 2x plus 30, so we put in x equals 9. 2 times 9 is 18 plus 30 is 48. And once again, we can check to see that these angles actually add up to 90. And sure enough, 42 and 48 add up to 90, so we are correct. Problem 7 again is similar to the prior 3 problems, but it has a different information about the angles, and that is it relates the two angles to each other. It says that the measure of angle B is 5 times the measure of its supplement, angle A. So there's two things we know. We know that angle A and angle B are supplements, so they add up to 180. We also know that B, the measure of B, equals 5 times the measure of A. So first of all, we know they're supplements. So measure of A and measure of B add up to 180. The other thing we know is that measure B equals 5 times the measure of A. So what I want to do is I'm going to use this information and substitute the value for B into the first equation. So notice the measure of A plus, instead of measure B, I put in 5 times the measure of angle A. That has 180. So if I have one item and I add 5 more of the same item, how many do I have? Well, we add those together. That means that 6 times the measure of A is 180. So let's solve that by undoing the multiplication with division, and we get that the measure of A equals 30 degrees. We want to find the measure of B. Well, we know that the measure of A and B add up to 180, but we also know that measure B is 5 times that. So what's 5 times 30? Or 150 degrees, and that's our answer. Let's do a quick check though to make sure they're still supplements, and notice that 30 plus 150 is 180, so we know that we have the right angles. They add up to 180, and 30 times 5 is 150, so we have the correct solution. Problem 8 is a matching exercise to help us with our vocabulary, to make sure we understand what these words mean. The first one says a perpendicular bisector. So we're looking for something that has a perpendicular and has a bisector, which means it cuts it in half. And right here, number 5, it's a line or segment or ray that is perpendicular to the segment at its midpoint. The midpoint is what we mean by bisector. We cut something into 2 parts, equal parts, so A is 5. B is a counterexample. Something that is counter is something that's against. So something, if somebody gives an example, something's true, and you give an example, something where it's false, that's a counterexample. So number 6, an example that shows a statement is incorrect. Letter C is the conditional statement. Well, the conditional statement we've been studying means it has the form of if this, then this. And so it's typically an if-then statement. So number 1 goes with C. Now our conditional statement is made up of 2 parts. Remember, if the hypothesis is the if part, so that's 8, then the conclusion, so for E is the then part. All right, so if the hypothesis, so D is 8, then the conclusion, so E is 4. Truth value means, is the statement true or false? The value of it, if you ask for the truth value of a conditional statement, you're asking, is it true or is it false? So number 9, true or false. One counterexample, by the way, will prove a false statement. But F is the truth value is either true or false. The converse is when you take a conditional statement and you take the hypothesis and the conclusion and switch them. Not the if and the then, that's just the hypothesis and conclusion. So number 2, if we exchange the hypothesis and the conclusion, so the converse G is number 2. A biconditional is when both the conditional and the converse are true. We can write them together with that statement of if and only if. So you notice number 3 here, an angle is a right angle if and only if it measures 90 degrees. So the matching for H is 3. And then what's a good definition? Well, one of the ways, there's many things. Being precise is one of the critical things, and being reversible, or we can write it as a biconditional, and that's what's given here. A definition is good if it can be written as a biconditional. So for I, we're going to put down 7. So we go on down here. Reflexive property. Reflexive property, you notice, means that you can see it different ways. For numbers, it just simply means that A equals A, or 1 equals 1, or 5 equals 5. For angles and segments, it means the segment RS is congruent to segment RS, and the angle T is congruent to angle T. So for J, we're going to put down 10. Symmetric property. Our symmetric property says if A equals B, then B equals A, and the same thing for segments and angles. If two things are equal to each other, I can switch the order and say they're still equal to each other. So K is 15. The transitive property is one in which if A equals B and B equals C, then we can assume that A equals C. You know, if I'm the same age as my wife, and my wife's the same age as her friend, then I'm the same age as her friend. So if A equals B and B equals C, then A equals C. And we have these not only for equality, but also for segments and angles. So the transitive property L is going to be number 16. Substitution property. This just means if two things are equal and I'm working in an equation, I can substitute its value in for the other in any of the equations. So down here, if A equals B, then B can replace A in any expression. So for M, we're going to put 24. In the addition property, says if an expression is equal, I can add the same thing to both sides and they'll still be equal. So let's find it here. If A equals B, then A plus C equals B plus C. So that's 13. O, the subtraction property, now it's just subtracting the same thing from both sides. So if A equals B, then A minus C equals B minus C, so that's 12. Our multiplication property, two things are equal, you can multiply them both by the same number and they'll still be equal. A equals B, then A times C equals B times C. 21 there. And then finally the division property. And if A equals B, and in this case making sure that C is not equal to 0, because we can't divide anything by 0, then A divided by C equals B divided by C, so that's 11. All right, those are 4 properties of equality we use all the time. Now we're to the segment addition. It means if I take two segments and add them together, the result is the total of their measures. So ED plus DF, the measure of ED plus the measure of EF equals the measure of the whole segment. So that's 19. Angle addition, similarly, if I add angles, notice if I angle AOB plus BOC is the same as the whole angle together. So that's called the angle addition. And T says if segment AB is congruent to segment CD, or if angle E is congruent to angle F. So what we're looking for here is they're just, this is kind of an odd one, because you're saying, what does that have to do with anything? Well, they're just showing you that this hypothesis goes with this. In other words, it's saying that if segments are congruent, then their measures are congruent. If angles are congruent, then their measures are congruent. And so 17 goes with the statement in T. U is midpoint. That's something in the middle. So notice here in 14, notice that F is in the midpoint. The two little dashes mean the segment on each side is exactly the same. V, supplementary angles. Those add up to 180. So let's find that. There it is right there. Two angles whose measures have a sum of 180. Notice they can be next to each other and form a straight line, but they could just be separate. They don't have to be next to each other. The V supplements mean that they add up to 180. And then complementary angle, the same thing, except they add up to 90. So notice here 18 have a sum of 90. Again, they don't have to be together like that. They could be separate, but if they add up to 90, they're complementary. And finally, vertical angles are angles that are across from each other. Notice 1 and 2 are vertical angles, and 3 and 4 are vertical angles. And vertical angles are congruent to each other. So we finished out our matching there. Problem 10, we're asked to state whether the statement is true or false. And if it's false, we need to give a counterexample. So for example, number A says, if an animal is a dog, then it is a great retriever. Well, is that true? Well, golden retrievers are dogs, but the statement that if an animal is a dog, it is a golden retriever is only true sometimes, not all the times. So we would say this is a false statement. And an example, for example, I give an counterexample of a poodle. A poodle is a dog, but it's not a golden retriever. B, all segment bisectors are perpendicular bisectors. Well, again, that's sometimes true, but not always true, so it's false. For example, here's a counterexample where I have a segment, a line bisecting this segment, but notice it's not perpendicular. So it is a bisector, but it's not a perpendicular. So there's my counterexample. Statement C, if there are 3 congruent sides, then the triangle is equilateral. Well, this is always true. That's what an equilateral triangle is by definition. All 3 sides are the same. So we don't have to give a counterexample because it's always true. D says if angle A and angle B are complementary, meaning they add up to 90 degrees, then they must equal each other. Well, that's false again. For example, I could give you 2 angles. Angle A is 30 and angle B is 60, not equal to each other, but 60 and 30 add up to 90. So there's a counterexample. Problem 11 asks us this question. Sally claims that when 2 angles have a common vertex, in other words, their point they have is the same, that they are vertical angles. And it wants us to do 2 things. First, create a drawing, including drawing markings to support her claim, and then create a counterexample. Well, the first one, notice here I've created this, and you can see that these 2 angles indeed have a common vertex right there. Okay, you see the common vertex? And indeed, they are vertical angles. They are equal to each other. So in that case, this is an example of where Sally's statement is true. They have a common vertex here, and they are vertical angles. However, I can easily draw a counterexample where that's not true. For example, here, these 2 angles have the same vertex here, right? But notice they're not equal to each other. I did that by giving different colors, but hopefully you can see they're not equal, and they're not vertical. They don't come across from each other. So in this case, we'd have to say that there's an example of where Sally's statement is true, but here's an example below in B where it's not true. So Sally's statement is Problem 12, we're going to use some of the things we've already done. It's kind of a 2-step problem. First of all, they want us to find angle LMD. Well, LMD is right here. And so what we're going to do there is we're going to look across and say, well, here's vertical angles, so I can set these equal to each other, find X, and find out what this is. On the other hand, they also want us to find another angle. This will be the second part. Well, LMH is right here. That's going to be a different amount. And we'll be able to find that because we can know that these two angles, you see, form a straight line, so they add up 180. So once I find this one, 5x, then I'll be able to find that one. So let's get started. First of all, let's find x. Because these vertical angles are congruent, I can state that 5x equals 2x plus 18. I have a two-step equation. So we're going to subtract 2x from both sides, get the variables on one side, and now undo 3 times x by dividing by 3, and I find that x is 6. With that information, now I can find what the measure of LMD is, because the LMD is 5x, so 5 times 6 is 30 degrees. So we've completed the first part. We found the measure of LMD. Now we want to find the measure of LMH. Well, I noticed that these two form a straight line, so they are supplementary. So the two angles add up to 180. So let me plug in the one I know, 30. So 30 plus the measure of LMH is 180. So let's subtract 30 from both sides, and we find out that the measure of LMH is 150 degrees. And obviously 150 plus 30 equals 180 for that check. And now we're done. Hope you do well on the test.